Good evening, students. Let's recap our last class. In our last class, we discussed basics of limits like uh, neighborhood of limit, limiting value of a function, and conditions for existence of the limit. And we also discussed some basic formulas, questions. Okay. In this class, we are going to discuss some more problems in which are usually asked in exam, mains and advanced. And one more thing, my video lectures are somewhat lengthy because I stresses in that particular areas in which students get struck of in exams, in mains and advanced, particularly in limits. In mains and advanced, the questions are can be solved within 2 to 3 steps max, but students uh, get less marks because mm, they will have doubt of themselves ki, whether their approach of doing that such question is right or wrong. Okay, so I stress in the particular areas like I use the words exactly, okay, need not, okay, then uh, some note points, okay, and slightly, okay. So you should be very careful with that. Like, let's take examples. Students get struck off with they don't know difference between, they get confused with respect to difference between exactly 0 power uh, 0 by infinity, 0 plus by infinity, okay, and this is exactly 0, this is tending to 0, and 1 plus whole power infinity, and exactly 1 whole power infinity, okay. Student gets stuck with this. And some more examples. Step of, this is step function, step of cos exactly 0, okay, and this gives value plus 1. Cos 0 is 1 and step of 1 is plus 1, but step of cos tending to 0, either 0 plus, this gives again value 0, okay. Similarly, step of cos 0 minus, this will give again 0. See how much different values you are getting. Similarly, students also get struck with some more examples like step of sine 0 minus, this is minus 1, okay. And step of sine 0 exactly 0, at exactly 0 it is again 0, okay. And there are some more examples you can think of. Step of cos cos again step cos x, okay. Okay, sorry. This is example, step of cos step x, okay. So these are the examples, and there are many more. And some oscillatory functions, students also get struck with oscillatory functions. Like, some oscillatory functions are divergent, some oscillatory functions are convergent, but student can't find whether it is divergent or convergent. Example, limit x tends to infinity sin x by x, okay. This is an oscillatory function sin x, but limit x tends to infinity, this function tends to 0 and this function tends to infinity, and this is 0, okay. But similarly, limit x tends to infinity, so this got converged, this oscillator function got converged, okay. But if you take limit x tends to 0 sine of cot x, ठीक है, sine of cortex. Okay, so this function never converges. Okay, why? Because this is very highly sensitive. Cortex is very highly sensitive. So sensitive in the sense कि for small variation in the x it oscillate ऐसे oscillate हो जाता है. So because of that sin x, let's take example. Cot 0 value is cos 0 by sin 0 is plus infinity. Okay, so plus infinity is here, so here, and sine of cos x. Okay, at x equal 0 it is plus infinity, and sine of cot x, like let's take example, limit x tends to just 0 plus. Okay, limit x tends to 0 plus, it is infinity. Okay, just 0 plus. Let's take example, it is ऐसे गिर गया cot x का value, this is plus infinity. Okay, and this is small quantity less than infinity. Okay, now, and this is x tends to some 0 plus h. Okay, so for the small variation in x, our cortex varied from infinity to some infinity minus k1. Okay, cortex varied from, this is infinity, this is infinity minus some k1. So this much variation or this much. Okay, so in between these two values, infinity and infinity minus k1, there might be a lot of, like, what is the sine graph? Sine 0 is 0, sine pi is pi. Okay, sine again, sine pi is 0. Okay, sine 2 pi, so it is vary from plus 1 to minus 1. Okay, with the difference of, within the difference of 2 pi, it is varying from plus 1 to minus 1. Okay, in this difference, infinity and infinity minus k1, there might be existence of n pi. Okay, or m pi, m is some positive number. Then sine, this is cot function. Okay, and sine of cot function, then it might have oscillated m times. Okay, yes. Okay, so this is highly oscillated, and this is never converges. Convergent means the function which never get into a particular finite value. Okay, so this function never converges. So these type of questions you should be very careful. Okay, so I'm thinking that you got my point, what I'm trying to say. And some in this class we are also going to discuss some problems which has unique approach to solve. If you choose some other approaches now, it is highly impossible to solve. Okay, in next lectures also we can solve that type of questions, but in case of existence of limit, let's take example, limit x tends to 0, function contains e power 1 by h terms. This have unique approach to solve, I will discuss. Okay, so please don't mind if the video is too lengthy. Okay, I like to spoon feed students. So let's go to our first question number 1. Okay, चलो so question number 1 is if f of x equals to x if x is even, okay, 1 minus x if x is even नहीं rational, ठीक है, if x is irrational then find what to find limit x tends to 1 by f of x, okay, this is our question. Okay, now how to proceed. So before this I want to talk about number line, okay. This is our real axis x, okay, so this is our 1 by 2, okay. So when I'm approaching from the left side of x towards x, you can observe there are infinitely real numbers, like infinitely real numbers, complex numbers also. In real numbers is also part of complex numbers. So you will observe infinite number of real numbers, the complex numbers, and in that real numbers you will observe infinite number of rational numbers and irrational numbers, okay. So I'm approaching from the left side, okay. Okay, यहाँ तक अप्रोच किया, then I stop here, okay. I approach till this point, I am finding my limit. So let's take example. This is h1 and this is 1 by 2 minus h1, okay. Okay, I stopped here, I approached till this point and let's assume that 1 by 2 minus h1 is rational number, okay. Then let's try to find the limit at this point, okay. This is our left hand limit. So it contains infinite number of real numbers, number line, and infinite number of complex numbers. Complex numbers can be if complex numbers is complex numbers is होता है कि x plus iy. So if you keep y equals 0, then it is again real number, okay. So in JEE you don't need complex numbers, so it contains infinite number. Let's say here it is there is real rational number, then there can be here irrational number, okay. Rational number, irrational number, irrational number, irrational number, rational number, is infinity, okay. So we assume, so this is our case 1, okay. We assumed limit x tends to 1 by 2 minus limit x tends to 1 by 2 minus f of x equals to limit h1 tends to 0 f of 1 by 2 minus h1, okay. Okay, so I assumed ki what is my assumption? 1 by 2 minus h1 is x equals to 1 by 2 minus h1 is rational. I assumed this. Okay. So when x is rational, what is my function value? It is x only. Okay. So substitute there. This is equals to 1 by 2 minus h1. Limit h1 tends to 0. Okay. So this value is 1 by 2. Okay. Now similarly, acha, note point. There is one note point here. Note point is if some real number minus some quantity, here we took h1. If it is rational, okay, then the same real number, okay, the real number minus h1 is rational, then the same real number plus h1 must be rational. Okay, must be rational. Okay. Second note we will discuss later. Okay. So here the real number in this example is 1 by 2. So we assumed x equals to 1 by 2 minus h1 is rational number. So then x by 2 plus h1 must be rational. So okay. So let's find right hand limit. Limit x tends to 1 by 2 plus f of x equals to limit h1 tends to 0 f of 1 by 2 plus h1. Okay. So since it is rational, again it is x, limit h1 tends to 0 1 by 2 plus h1. This is again, since h1 tends to 0, this is again 1 by 2. Okay, good. Next, we got left hand limit equals to right hand limit for x is rational. Okay, so that's the case. In the case 2, what is the case 2? Case 2 is when I'm approaching from this side towards x. Okay. Now I approach it till that point x, which is irrational, not rational. Okay. So which is irrational. This is, I approach till this point 1 by 2 minus, now I give some new quantity h2. Okay, h2, this difference is h2. Okay, so before we took a rational, we approach till the rational number, now we approach till the irrational number. Okay, so because beside 1 by 2 there are a lot of both rational and irrational, so let's find left hand limit. So we took x equals to 1 by 2 minus h2 is irrational. irrational. ठीक है, ठीक है, गुड गुड. So let's find left hand limit. Limit x tends to 1 by 2 minus f of x equals to limit h2 tends to 0 f of 1 by 2 minus h2 equals to, here 1 by 2 minus irrational, so our f of x is 1 minus x. So limit h2 tends to 0, it is 1 minus, ठीक है, 1 by 2 minus h2, ठीक है, what point 1 minus 1 by 2 is 1 by 2 plus h2, and this is tending to 0, so this value is 1 by 2. Okay, similarly limit, okay, here one more note point. Note point is, if x some, if there is some number like real number plus some real number minus some number, here it is h2 in this example, is if this number is irrational, okay, the real number minus some quantity or some number is irrational, then the same number plus the same quantity h2 must be irrational, okay, remember this. Okay, so here the real number is 1 by 2 plus h2 must be irrational. So let's find right hand limit here. Okay, limit x tends to 1 by 2 plus f of x equals to limit h2 tends to 0 f of 1 by 2 plus h2. Okay, limit h2 tends to 0, since f of x is irrational number, so we will have the case 1 minus x. Okay, so it is 1 minus, okay, 1 by 2 plus h2, ठीक है, good, well done. So this is 1 by 2 plus 1 by 2 minus h2. Since h2 tends to 0, it is again 1 by 2. Okay, so in this type of problems you should see both, मतलब here for irrational also we got left hand limit equals to right hand limit, ठीक है. So in this type of problems we should see both for rational and irrational, that the limit must be same, not just rational, not just irrational. There also we got left hand limit equals to right hand limit, that is equals to 1 by 2. Here also left hand limit equals to right hand limit equals to 1 by 2. Then only limit adjust. If the irrational limiting value of function tends to some 5 and rational tends to 1 by 2, then limit does not adjust. Okay, so let's go to next problem. Okay, question number 2, limit x tends to 1 plus 2 power minus 2 whole power 1 by 1 minus x. Okay, this is our problem. They are asked to find limit of x tends to 1 plus 2 power minus 2 power 1 by 1 minus x. Students, I already said you people whenever they asked the limit with some symbol here, we don't need to find both LHL and RHL, but we should find only one limit what they mentioned. So here we should find only limit x tends to 1 plus, no need to find 1 minus. Okay, and we don't care about whether the limit exists or not. Okay, so be careful. Okay, so limit x tends to 1 plus f of x equals to limit x tends to 0 f of 1 plus h equals to limit h tends to 0. Okay, good. 2 power minus 2 whole power 1 minus, okay, 1 plus h. ठीक है, good. 1 cancel, that comes as 2 power minus 2 and this is minus 1 by h. Okay, this is equals to 2 power minus, this we can write as 1 by 2 power minus 1 by 2 power 1 by h. Okay, a power minus m equals to 1 by a power m. Okay, so this is equals to again a power minus m is 1 by a power m, 1 by 2 power 1 by 2 power 1 by h. Okay, so let's erase this. So we got 1 by 2 power 1 by 2 power 1 by h. Okay, so now limit x tends to 0, limit h tends to 0, 1 by h tends to, since h is positive, okay, 1 by h must be tending to infinity, plus infinity. Okay, plus infinity. Okay, so again 1 by 1 by h tends to 0. So okay, this is not 1 by 1 by h, this is 1 by 2 power 1 by h. Okay, so 2 power 1 by h equals to 2 power infinity equals to infinity. Okay, and 1 by 2 power 1 by h equals to 1 by 2 power infinity equals to 0. ठीक है, since 1 by infinity is 0, and again 2 power 1 by 2 power 1 by h equals to 2 power 0 tending to 1. Okay, so our question is 1 by 2 power that equals to 1 by 2 power 0 equals to 1. So did you understand? Good. So the value is 1. Here we want to find left hand limit, and we don't know whether this limit exists or not. Left hand limit may not be 1. Okay. So let's go to next question. Hard question. So our third question is question number 3. Okay. If A and B, if A and B are positive, okay, and step x denotes greatest integer function less than x or equals to x, less than or equals to x, then find limit x tends to 0 plus x by a, okay, into step of b by a, b by x. Good. So here this is the question. So I will say where do student do mistakes here, only possible mistakes. Ki here you should observe one thing. Let's take example. Okay, they ask directly right hand limit. So limit x tends to 0 plus. This is limit h tends to 0 f of 0 plus h. Okay. So if you keep h here, this is 0 plus h by a by b by 0 plus h. Okay. So here if you solve directly, what happened? Let's take example. H equals to 10 power minus 40, because h is positive, you know, 10 power minus 40 is positive, and h is infinitely small quantity. This is also infinitely small, very very small. Okay. So this is our example. Now here b, coming to b, okay, coming to b by h. So b by h value, what you will see here, b can be any, they said b positive, b can be, let's take example 1, then b by h value is 10 per 40. If b is 1, then b by h value is 10 per 40. Okay. If b is 2, then b by h is 2 into 10 per 40. 3 then it is 3 into 10 per 40. So let's, if b is 10 per 40, then b by h is 10 per 80. Okay. So in this case, this value and step of 10 per 40, since 10 per 40 is integer, step of 10 per 40 is also 10 per 40. Okay. So this is same as this, h by a, this is into 10 power 40. Okay. And since h is tending to 0, h is tending to 10 power minus 40, So this is something 1 by a, okay. But what if case 2? What if I take b equals to 10 power 100 and h equals to 10 power minus 40? Then inside bracket we will get 10 power 160, 10 power 140. So step off again, 10 power 140 is 10 power 140, okay. So 10 power 140 in, so h by a into 10 power 140. Again h is 10 power minus 40 into 10 power 140 is 10 power 100 by a. Before we got 10 power, before we got 1 by a, and here we are getting, okay, 10 power 100 by a. So this is this value is, you can see 10 power 100 by a and 1 by a, they are completely, there is too much difference, okay. If you take 1 also, a equals to 1, there is lot of difference. So the value is not converging to a particular value. So don't do mistake. So the approach here is limit x tends to 0 plus x by a. Step of b by a we can write as b by a minus flower bracket of b by a, okay. So now this we can write as limit h tends to 0, okay. E by h, okay. So here we can cancel out h, so this value is b by a, and minus h by a, okay, b by h, okay. So here if you observe one thing, in before example we took b equals to 10 power 100, okay. So if you keep b equals 10 power 100 and h equals 10 power minus 40, then this is, let's keep it as b by only, minus h by a, okay. This value is flower bracket of 10 power 100 by 10 power minus 40 is 10 power 140, okay. This value is 10 power 140. Suppose flower bracket of 10 power 140. Flower bracket, you know, flower bracket of all integers is 0, okay. So this value is 0 irrespective of h by a. Let's take example b by b is not 10 power 100. Let's take example b is 10 power 100 plus some 0.1, okay. Then this value is, we are not substituting initially, okay, minus h by a, again flower bracket of b by h. B is this much, 10 power 100 plus 0.1 by h is 10 power minus 40, okay. still okay, not 10 power minus 40. Here we are getting integer. So 10 power minus 40 plus some 0.1. So still this will give some 10 power 140 plus something 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 point. Okay. So again, but this whole value, whatever you get, whatever point value you get, but the flower bracket must be flower bracket must be less than 1, and flower bracket must be positive. Okay, it must be less than 1 and it must be positive. Okay, समझ में आ रहा है? Good. So this value is less than 1. Okay, and this is multiplied by h by a, and this is b by a. Okay, good. So minus. Now since it is tending to 0, very small h, 10 power minus 40, so this value is tending to 0. Okay, minus 0, and this is b by a. Okay, understand? So in before example, when we I said no students do mistake there. If you observe, if you have noted ki the final answer is dependent of b. If you substitute different b values, now the answer is changing, but here the final answer is in the b by a form. Okay, so this is our answer. Let's go to next example. So answer is b by a. Next question. Okay, fourth question. Question number 4. f of x equals to x plus 1, x greater than 0. ठीक है, 2 minus x, x less than or equal to 0. ठीक है, g of x equals to x plus 3, x less than 1, x square minus 2x plus 2, square minus 2x minus 2, 1 less than or equals to x less than 2, x minus 5, x greater than or equals to 2. ठीक है, so our question is find limit x tends to 0 g of f of x. Okay, so this is a model of function of a function. Okay, so how to deal with function of a function questions? So here let's find left hand limit. Limit x tends to 0 minus f of x. So here initially node point is This is a note point. Note point is when our question asks function of a function like g of f of x limit, okay, then find limit x tends to 0 or f of x first, okay. So whenever they ask the questions like function of a function, then you should find the inner function limit of inner function at same value x tends to 0, okay. Then comes to outer limit. I will say how to proceed, okay. So here left hand limit x tends to 0 minus, so I said to find inner limit first. F of x equals to limit x tends to 0 minus is x tends to 0, f of 0 minus h equals to, okay, good, limit h tends to 0, f of 0 minus h, since h is positive, h is infinitely small, okay, h is positive, so 0 minus h must be less than 0, so then our case must be this case, which is x less than 0, x less than, so our case is 2 minus x case. So limit h tends to 0, f of 0 minus h is 2 minus 0 minus h, okay. So this is 2 minus 0 plus h. And again, here we should also note one more point. Note point is, so when you find the inner limit, now limit x tends to 0 f of x, so we got it is 2.2 plus h, okay, and don't try to substitute h equal to 0 there, just leave it 2 plus h. You should substitute afterwards, okay. So don't try to substitute h equal 0 here itself. So now carry to original function, limit x tends to 0 g of x, f of x equals to, we can say, limit h tends to 0 g of f of x is g of, substitute this 2 plus h directly here, 2 plus h, okay, g of 2 plus h, good. This is, now since h is positive and h is infinitely small, since h is positive means 2 plus h, let's take example, h is 10 power minus 40, 2 plus h is 2 plus 10 power minus 40, so this, it 2 plus 10 power minus 40 must be greater than 2, so our case must be this case, okay, because that is x less than 2, that is x less than 1, so function of g of x is x minus 1. In place of x we have 2 plus h, not x, okay. So substitute 2 plus h here, limit h tends to 0, 2 plus h minus 5. Now you can substitute h here, so h tends to 0, this is minus 3, okay, good, nice. Again, let's find right hand limit. Right hand limit x tends to 0 plus g of f of x equals, similarly limit h tends to 0, so similarly we should g of f of 0 plus h. So I said to find inner limit first. Okay, so inner limit h tends to 0, f of 0 plus h equals to 0 plus h is positive, I said. So this is limit h tends to 0, 0 plus h plus 1. So again, don't substitute directly h here. Okay, so keep it 1 plus h. Now coming to g of x, original function, limit x tends to 0 plus g of f of x. Substitute this 1 plus h directly here. Okay, so it is limit h tends to 0, g of 1 plus h equals to, okay, good, g of 1 plus h. Since h is positive, 1 plus h must be positive, must be greater than 1, not positive. So where is greater than 1? If here between 1 and 2 we will have greater than 1. So our function is x square minus 2x plus minus 2. In place of x we have 1 plus h, so substitute there. Limit h tends to 0, 1 plus h whole square minus 2 into 1 plus h minus 2. This is 1 plus h square plus 2h minus 2 minus 2h minus 2. Okay, good, nice. Since minus 2h plus 2h cancel, minus 2 plus 1 minus 3, and h is my 10 power minus 40 we said. So h square is 10 power minus 80. It is very small compared to minus 3. So answer is minus 3. ठीक है, understand? Good. ठीक है. So we got left hand limit is minus 3 and right hand limit is minus 3. So we can say limit exist. The value of limit is minus 3. Okay, let's go to the next question. Okay, question 5. Limit x tends to 2 plus step x minus 2, okay, log of x minus 2. ठीक है, so this is our question. So here also if you observe, they asked only right hand limit, not left hand limit or 10 to 0. They gave symbol 2 plus, so we just need to find right hand limit. We don't need to find left hand limit, so we can write it as limit h tends to 0 f of 2 plus h. अच्छा, स्टूडेंट्स की हर बार always make habit of writing in the form of h, not x, because in especially MCQ, not integer questions. Integer questions limit always exist and they ask only limiting value, so limit must exist. But especially in MCQs, there will be many cases where limit does not exist, so student will get struck off. So that's why make habit of doing with this and find both LHL and RHL. If you do with x, you get out of root. Okay, so try to make habit of doing this. So this is step of 2 plus h minus 2 by log of 2 plus h minus 2. This is step of h by log h. ठीक है. Now since h is positive and h is infinitely small, 10 power minus 100 example, so it is very tending to 0. So if you draw log graph now, log graph at x equals 0, it is comes from minus infinity and touches here at x equals to 1, it is 0, log 1 is 0, it is minus infinity at x equals 0. Okay, so x tending to 0 plus log h is tending to minus infinity. As x tends to 0 plus log x tends to minus infinity. Okay, now again I said already, so here our value is step x step h by minus infinity. Since h is very small but just greater than 0, step of, and it is less than 1 also. Okay, so step h is between 0 and 1, so step h must be 0. Okay, exactly 0, not tending, exactly 0, integer, so it is exactly 0, very important, exactly 0. Okay, exactly 0 by infinity minus infinity. Okay, exactly 0 by minus infinity. Students, note this point here. Note point is exactly 0 by, this is exactly not tending to 0, not tending to 0. Exactly 0 by infinity is 0. 0 by infinity power infinity is also 0. 0 by anything, exactly 0 by anything except 0. Here in place of infinity, if you have 0, you can't, it is undefined. 0 by anything other than 0, this value gives 0. Okay, this is very important when we deal with limits of this type. So because 0 by 0 is undefined, you will get different values of answer. Okay, 0 by 0 for 0 by 0. So this value is 0. ठीक है, so they ask only right hand limit, so answer is 0. Let's go to next question. So next question is, okay, sixth question. Limit x tends to 0 e power 1 by x minus 1 by e power 1 by x plus 1. Okay, e power minus 7 by x, e power 1 by x minus 1 by e power 1 by x plus 1. Okay, I told you that there are, for some questions there will be only unique approach. If you try to do with other approaches, no, then you don't get exact answer. Okay, so this is one such type of question. So let's try to find left hand limit. Limit x tends to 0 minus, ठीक है, f of x equals to limit x tends to 0 f of 0 minus h, ठीक है, equals to e power 1 by 0 minus h minus 1 by e power 1 by 0 minus h plus 1. Okay, good, thank you. So here this is e power minus 1 by h minus 1 by e power minus 1 by h plus 1. Okay, limit h tends to 0. What is the value of e power minus 1 by h? बताओ, limit h tends to 0, what is the value of e power minus 1 by h? You don't know? Okay, I will say. So this is e power 1 by minus 1 by h tending to 0, then minus 1 by tending to 0, minus 1 by tending to some, minus 1 by some value tending to 0 is this quantity, na, this will tend to minus infinity. Okay, so e power minus infinity. So if you see graph of e power x, e power minus infinity, e power x graph at x equals to minus infinity is 0. ठीक है, so you can substitute this value there. So if you substitute now, what you will get? You will get e power minus 1 by h minus 1 by e power minus 1 by h plus 1 equals to 0 minus 1 by 0 plus 1. This is minus 1. Clear? Good. Again, let's try to find right hand limit. Right hand limit. So if you try to find right hand limit, limit x tends to 0 plus. So I will say now how student can do mistake. Okay, then I will say the correct method. Let's approach from the student's side view. So student do mistake here ki he will directly substitute limit. This is f of x equals to limit h tends to 0, f of 0 plus h equals to e power h minus 1 by e power 1 by h plus 1. ठीक है, my handwriting is very bad. So this is h tends to 0, this is plus infinity minus 1, this is again plus infinity plus 1. Okay, students, yeah, plus infinity by plus infinity, uh, it is an indeterminate form. Okay, we don't know exact behavior of such type. We can't say the exact behavior of such type of functions. Okay, so we will discuss in the coming lectures about indeterminate forms. But here question comes. So when we get indeterminate forms, so we should try to eliminate such quantities which made the function is indeterminate. Limiting function is indeterminate. This is the quantity which is making the function indeterminate. So we should try to remove that by doing some manipulations. So student get stuck up there. Okay. So what we can do here? Take common e power 1 by h 1 by x. Okay, limit x tends to limit h tends to 0 e power, this is e power 1 by h minus 1 by e power 1 by h plus 1. Okay, good. ठीक है, take e power 1 by h common, then we can write 1 minus e power minus 1 by h. Okay, this is 1 plus e power minus 1 by h. Okay, good. These two terms can be cancelled out. Now remaining term is 1 minus e power minus 1 by h by 1 plus e power minus 1 by h. When h tends to 0, I said already, this is tending to 0. This is 1 minus 0 by 1 plus 0. This is plus 1. Okay, clear? Thank you. Next, so in this question we got left hand limit equals to minus 1, right hand limit equals to plus 1. So left hand limit is not equals to right hand limit, so this means limit does not exist. Does not exist. Okay, good. Clear? Okay. Next question. Next question is question number 7, I guess. Consider the following graph. Of a function y equals to f of x. Which of the following options are right? Okay, given y some function y equals to f of x, they are asking which of the following correct options. Okay, at x equal to 0, at x equal to 0, the value of f of x is plus 1. Okay, y equals to f of x, and x equals to 1, the value of function is 1 itself. At x equal to 0, the value of function is 0 1, and x equals to 1, the value of function is 0. So and in between the value varies like this, y equals to mx, and here from this is 2, from 0 to 1, as x varies from 0 to 1, y varies from 1 to 2, and exactly x equals to 1, at x equals to 1, y equals 0. Okay. Next, 3. Again, here this represents the function is jumping from here to here. Okay, at x equals to 1, the value is 0. So here again, at x is greater than 1, what is the value? They given like this. Okay, and this is x. At x equals to 2, again they given values again 2. Value is 0. At x equals 0, it jumped from here to here, sudden jump here to here. From 1 to 2, the value of f of x is 3, and at x equals to 2, the value jumped from 3 to 0. Okay, this is value 0. Again, at x equals 2 plus, the value again ऐसे आया, again it got jump here at x equal 3 0, again ऐसे गया. So this is our question. So first option, they are asking which of the following options are right. Limit x tends to 1, f of x does not exist. Okay, so let's find left hand limit first. Conventionally, limit x tends to 1 minus f of x, limit h tends to 0, f of 1 minus h equals to, okay, limit h tends to 0, f of 1 minus h is greater than 0, so 1 minus h is just less than 1. So if you see graph now, if you at x equals to 1 and 1 minus x, the value is tending at 1 minus x, 1 minus h, the value is tending to 2. Okay, just less than 2. Okay, so we can write some list like this is this value is, this is 2, this is 2 minus k. Okay, good. So this is 2 minus k, and k is very small since it is a continuous function. Next, limit x tends to 1 plus f of x equals to limit h tends to 0, f of 1 plus h equals to, since h is positive, this 1 plus h must be greater than 1. Okay, so 1 plus h must be greater than 1. So this is x at x equals to 1, and 1 plus h must be here, 1 plus h, and the corresponding y is 3. Okay, so this value is 3. So left hand limit is 2 minus k, and right hand limit is 3, and k is positive, so these two left hand limit not equals to right hand limit, implies limit does not exist. So first option is right. Okay, good. So let's go to option B. Students, here I am doing spoon feed. Okay, so here B, limit x tends to 2, f of x does not exist. Okay, option B, we should see whether it is correct option or not. Okay, so here is this. Okay, So like left hand limit. Limit x tends to 2 minus f of x equals to limit h tends to 0 f of 2 minus h. Good. And 2 minus h is less than 2. So this is, let's take example. This is 2 minus h somewhere here. So corresponding y value is plus 3. Is plus 3. Okay. Similarly, limit x tends to 2 plus f of x equals to, okay, limit h tends to 0 f of 2 plus h equals to, again similarly, when h tends to 0 f of 2 plus h is positive, so 2 f of 2 plus h is positive means f of 2 plus h corresponding y is again plus 3. Okay, plus 3. So left hand limit is equals to right hand limit, what they given means, this means limit exists. Okay, what they given limit does not exist, so this is wrong option. So there is one note point here, very careful. In this example, in the option B, before option also, at x equals to 2, the value of f of 2 is 0. Okay, f of 2 minus is 3, f of 2 plus is 3. So for seeing existence of the limit, we don't care about the value at x equals to 2. We just care about x equals to 2 minus x equals to 2 plus. Okay, if they are equal, then our limit exists. We don't, no need to talk about what happens at x equals to 2. Okay, left hand limit is plus 3, right hand limit is plus 3, then done, our limit exists. So option B is wrong. They given limit does not exist. Okay, so let's go to option C. Option C is limit x tends to 3, limit x tends to 3, f of x equals to 3. Okay, good. So let's find left hand limit. Left hand limit equals to limit x tends to 3 minus f of 3 minus h. Okay, okay, this is again, so this is 3 minus h, this is 3, and 3 minus h might be here. Okay, just less than 3, and corresponding y value is 3. Okay, so this is 3. Similarly, limit h tends to 0, f of 3 plus h, 3 plus h is here just greater than 3, h is positive, so again limiting value of that function is 3. Okay, good. Okay, so left hand limit is right equals to right hand limit, so limit exists. They given same, so option is right. Next question, next option. This is very important, this is very nice option. Limit x tends to 1.99 f of x exist. This is very very good question. So let's see. I want to rewrite the diagram. These are the diagram. So this is the given one. Okay, 2 and again 0, x equals to 2, and this point again. Okay, so it's the so left hand limit x tends to 1.99 minus. Okay, they are asking limit x tends to 1.99, which is somewhat good. So 1.99 we can write as limit x tends to 1.h tends to 0, f of 1.99 minus h. Okay, this is equals to so this is equals to 1.99 minus h. Let's zoom this. Zoom करो थोड़ा सा प्लीज. This is 1.99. This is 1.99 minus h. Okay, so corresponding y value is 3, so limiting value is 3 as h is less than 0. Now comes to right hand limit x tends to 1.99 plus. So here comes the question, can we say 1.99 plus is 2? Can we say since 1.99 plus it is equals to limit h tends to this is equals to 1.99 plus h. Since h is positive, can we say 1.99 plus h is 2? No, you can't say. Why? Because I said already h is infinitely small. 10 power minus 80, let's take example. 10 power minus 80. This is still less than 2. समझ में आ रहा है? Note, this is very important. ठीक है? Plus 10 power. H is 10 power minus 80. This is still less than 2. So 1 point h doesn't mean that it is equals to 2, okay, or greater than 2. It is still less than 2. So here 1.99 plus h will be there, and it is still less than 2, and the corresponding y value is still again 3 only. So समझ में आ रहा है? अच्छा, of 1.99 plus this is again 3. So both values equals to nothing, then we can say limit adjust. Okay, good, thank you. So let's go to the next question. Our next question is the 9th question. Limit x tends to 0 tan of signum x by signum x. ठीक है? They are asking limit x tends to 0 tan of signum x by signum x. what is function signum x? Okay, signum x is equals to -1. This value of signum x is -1 if x is less than 0. For all values x less than 0, the value is -1. Okay, for all values x less than 0, this value is 0, x, but x exactly 0. If x is 0, then signum x is 0. Okay, and its value is +1 if x greater than 0. ठीक है, for all values greater than 0 is +1. if you see through graph, signum x ऐसा होता है. देखो, at x equal 0 its value is 0, at x greater than 0 this value is 1 +1, and x less than 0 the value of this is -1. Okay, but x equal 0 it is 0. For all values -1 +1 0. So now our question is limit x tends to 0 it is. So let's take example, let's take left hand limit. Left hand limit is limit x tends to 0 minus f of x is limit h tends to 0 f of 0 minus h. Okay, good, thank you. Limit h tends to 0 f of 0 minus h, this is tan of signum 0 minus h by signum 0 minus h. Since h is positive, 0 minus h is less than 0. This quantity is less than 0. This quantity is less than 0. So I said for all quantities less than 0, signum value is -1, -1. Okay. So this is tan of -1 by -1. Since tan -1 is will be is at fourth quadrant. Okay, so this is -1.57 minus pi by 2, so this is 0. So -1 must be in the fourth quadrant. So tan of -1 is minus tan 1. In fourth quadrant, tan of something minus is minus, something is minus tan 1. So it is -1 is cancelled. The value is tan 1. Okay, good. Next, similarly we can find right hand limit. Okay, limit x tends to 0 plus this sum f of x is limit h tends to 0 tan of signum 0 plus h by signum 0 plus h. Okay, good. So again, signum 0 plus h, 0 plus h is positive, 0 plus h is must be positive, and I said signum values for all positive is +1. Okay, so this is tan +1 and this is +1, this is again tan 1. So we got left hand limit is +1 or tan 1 and right hand limit is tan 1. So हमारा लिमिट एडजस्ट हो गया. Okay, next question. Next question is question number 10, I guess. Limit x tends to 0, step x whole square by x square equals to L. Okay, good. Limit x tends to 0, step x square by x square equals to M. This is greatest integer function less than or equals to. Then they are asking which of the whether L is limit L is adjust or M is adjust. Okay, let's consider this function. So left hand limit, let's find left hand limit. Limit x tends to 0 minus f of x equals to, okay, good. Limit h tends to 0, f of 0 minus h equals to limit h tends to 0. Okay, this is step of 0 minus h whole square, 0 minus h whole square. Okay, understand? And here 0 minus h is negative, step of negative but just less than 0. Okay, it is between minus 1 and 0. Okay, so values, step of values which are between minus 1 and 0 gives minus 1. So this value is minus 1 whole square by h square. This is 1 by h square. This is plus infinity. Okay, h is 0, that's 0, so 1 by h square is plus infinity. So again, let's find left hand limit also. Similarly, right hand limit, limit h tends to 0 plus f of x equals to limit h tends to 0, f of 0 plus h. Okay, good. So this is equals to limit h tends to 0, this is 0 plus h whole square by 0 plus h whole square. Okay, so 0 plus h whole square. Since 0 plus h is quantity, h is positive, 0 plus h is must be positive, but just it is between 0 and 1 and very near to 0. Okay, and step of values which are in between 0 and 1. Okay, step of values which are in between 0 and 1 is 0, exactly 0, integer, exactly 0, not tending to 0. Okay, so step of h is 0 and square, this is h square. 0 square is 0 into 0 is 0, exactly 0 by h square. Here also exactly 0 by anything except 0. Here is h is not 0, tending to 0. H is not 0 but tending to 0. So 0 tending to 0 whole square, exactly 0 by tending to 0 whole square is 0. Okay, don't get confused, student get confused between 0 and h. H is not 0 but tending to 0. Okay, just positive quantity. So exactly 0 by tending to 0 is again 0. I said exactly 0, any value except 0 is 0. Okay, so left hand limit is not equal to right hand limit. So limit does not exist. Okay, good. Left hand limit we got plus infinity and right hand limit is 0. So limit does not exist. Similarly, limit x tends to 0, step x square by x square. Okay, good. So left hand limit is now let's find left hand limit. X tends to 0 minus f of x equals to limit h tends to 0 f of 0 minus h. Okay, this is equals to h is less than 0. Okay, so there 0 minus h whole square by 0 minus h whole square. ठीक है, good. Step of 0 minus h whole square. This is step 0 minus h whole square is h square. 0 minus h whole square is h square. And again, this is h square is positive quantity and h square is more less than h. So, and it is again between 0 and plus 1. So it is 0, exactly 0 by h square. I said already. Again, this is 0. Okay, good. So let's find right hand limit. Right hand limit. Limit x tends to 0 plus f of x equals to limit h tends to 0 f of 0 plus h. Okay, good, nice. So substitute there. This is 0 plus h whole square step up by 0 plus h whole square. ठीक है, again h square is positive, step of h square by h square. H square positive and it is between 0 and 1. H square is 0 and between 0. This is again 0 by h square. Okay, this value is again 0 by h square is equals to 0. Okay, clear? Good, thank you. So left hand limit is right equals to right hand limit. So our limit exists. So next question. Question number 10. Limit x tends to minus 1 by 3 minus 1 by x minus 1 by x. Okay, good, thank you. Okay, so here also they asked to find only left hand limit, not right hand limit, because there is symbol of minus. So we don't care whether limit exists or not, we just find left hand limit. So we can write as limit x tends to minus 1 by 3 minus equals to limit h tends to 0 f of minus 1 by 3 minus h. Okay, good. This is equals to, substitute there, 1 by minus 1 by 3 minus h. This is equals to minus 1 by minus 1 by 3 minus h. If you take common minus here and minus minus cancel, okay, then we will get here also minus common, minus 1 plus h, step off, this is minus 1 by 3 plus h, this is into step off 1 by 3 plus h, numerator लेके जाओ 3 by 3 plus h. Okay, 3 by 3 plus h. Let's talk about this. 3 by 3 plus h. Okay, so since h 10 power minus 80 example, then 3 plus h is 3 plus 0 3 plus 0 0 0 0 1, 8 digit. So 1 plus 3h. Okay, sorry, 1 plus 3h. So it is 1 plus 3h, 0 0.00003. Okay, so it is just greater than 1. Okay, 3 by 1 we know it is 3 by value of 3 by 1 is 3. So 3 by 1 plus 0, so it is 1 plus 1.00003. So its value is just less than 3. Okay, understand? Okay, good. So the value of that is minus 1 by 3 plus h. So this is just less than 3, so its value is 2. Step of just less than 3 is 2. So again, now substitute h equals to 0 here. This is minus 1 by 3 into 2 is minus 6. Clear? Understand? Okay. Next question. Question. Limit x tends to 0 plus x whole power log x base e. Nice question. X tends to 0 plus log x base e. Here also we should find only right hand limit. No need to find left hand limit. Okay. Be careful. Be careful. Achha. So here, so it is, we can write as limit h tends to 0, 0 plus h whole power log of 0 plus h base e. Okay, log of 0 plus h base e, I said it is tending to minus infinity. I said before example, before example maybe. So it is h power minus infinity as h tends to 0. I said log is tending to minus infinity. Okay, so this is equals to 1 by h power infinity. Okay, good. 1 by h power infinity. When h tends to 0, this is very small and tending to infinity. So just greater than 0 plus tending to infinity is tending to 0 plus just greater than 0. So it is again tending to 1 by 0 plus is tending to plus infinity. Okay, समझ में आ रहा है? So right hand limit is plus infinity. Very easy question. What to hold? Next question. Next question is okay, and this is our last question also. Okay, this is the question. Okay, I got it. Call the question. Limit x tends to infinity. E power x plus 5 power x. Okay, whole power 1 by x. Okay, where denotes fractional part of x. Okay, good, nice. So बच्चों, so how to proceed? So here take common. Limit x tends to infinity. Note here, note that there is no difference between if you left hand limit of infinity is infinity minus and right hand limit is infinity plus. So if you take, there will be no difference. Both are, because it is tending to infinity. Infinity is not exact a number. Okay, so infinity minus infinity plus, there is no nothing. So you can just try directly substitute x directly there. Okay, so flower of take e power x common, 5 power x common. Okay, 5 power x power n by x is pi, e by pi whole power x plus 1. Okay, again power 1 by x flower. So this let's talk about e by pi whole power x. E by pi whole power x, e equals to 2.7 and phi is 3.14 something. Okay, so this quantity is less than 1 power infinity. Okay, so this value is tending to 0. Okay, good. So tending to 0, 1 plus tending to 0. So 1 plus some value tending to 0 is tending to 1. 1 plus some value, this is tending to 0, plus 1 is tending to 1. Okay, good. Plus, and since x is tending to infinity, 1 by x 1 by x tending to 0. Okay, so this value is 1 plus whole power tending to 0. This value tends to plus 1. Okay, 1 plus okay, plus 1. So now plus 1 flower of pi. What is the value of flower of pi? So since pi is 22 by 7, okay, what is the meaning of flower of pi? It is the quantity which is just fractional part which is just greater than integer. Okay, you can write this as step of 3 plus 1 by 7. Okay, so this is again step of 3 plus 1 by 7 is 1 by 7. Okay, good. So this value is 1 by 7. This is, we can also write 5 minus 3. Okay, so students, let's end up this session here. It's too long, I know, but this will make your concept clear. Okay, thank you. We will meet in the next session. Bye bye. Okay.